Hello, Amsterdam. Welcome to today's talk. I wish you a warm welcome. How's everybody doing? You're doing good? Yeah? Okay, cool. Wow, look at you. So many of you. Who says dreams don't come true, right? Okay, today we're going to talk about loading web performance, and we're going to discover some secret shortcuts to it. But before we do that, we should have like an developed critical thinking. That is like a crucial skill in every engineering job, right? So we're going to ask all these important questions about web performance and see how important are those questions. Yeah, I will try that. Thank you for that. I will try to speak louder. OK, so let's start with why. Has anybody read a book from Simon Sinek, Start with Why? Anybody? OK, a few of you. I don't know about you, but the main takeaways from that book for me was like that people who know why they are doing something, they are much more purpose-driven, they are much more motivated, and there is much higher probability that they are going to do task properly. So that's really important for us as engineers. So let's get motivated about web performance. If we Google a little bit, we can find information like these. And these. And these. I don't know about you, but this seems really compelling to me, right? OK, now that we are properly motivated about the performance, let's ask a question, where to look. Once we open our domain of our app in the URL, what happens if we open developer tools and look at the network tab? So we start to download the index.html file, right? And that file has the links to some style sheets, some JavaScript, images, fonts, and so on. So optimizing the delivery of those files back to our browsers is what we call loading web performance. And fetching of those resources sometimes can be slow and expensive, and it can depend on internet speed, size of those resources, location of the server, and the number of request round trips. So this is a bit tricky to do. And of course, user devices. I'm going to quickly introduce myself. When I was in high school, I always wanted to study psychology. Now I work my dream job as a development lead at Vega IT, where I teach soft skills for engineers. I teach people how to communicate effectively with the clients, how to deal with estimates, stress management, time management, and stuff like that. Also, I'm a technical architect. My name is Nikola Mitrovic, and these are secret shortcuts of loading web performance for you for today. So let's begin. For the people in the back, I'm going to show some code snippets. So if you don't see it properly, you can scan this and you can follow the presentation along with me. You can put it maybe in the portrait mode, and you can see better the code. So I will give you a sec to do so. OK, we good? Great, thank you. I'm going to jump straight to the point by saying that the JavaScript is the biggest bottleneck of web performance. And the size, specifically the size that we're shipping into the browsers, is the problem. Because that can cause delays with the loading, rendering, user interaction, and even scrolling. So basically, it affects all web vitals. And it's the biggest bottleneck. If we Google a little bit or ask ChatGPT about it, what can we do? How can we optimize the JavaScript? We can minify it. We can compress it with certain algorithms. We can remove unused code with tree shaking, right? We can analyze the bundle size with, there is a Webpack and Wheat analyzer, so we can visually see what parts of our bundle is the biggest. We can use import cost web plugin, Visual Studio Code plugin, sorry. And we can check a library size with this cool website called Bundlephobia. How many of you have used Bundlephobia before? OK, quite some of you. But for you who haven't, I'm going to quickly show it. So this is Bundlephobia. And let's go with some classic like Moment.js, which is like deprecated library these days. Whoops, that shouldn't happen. But you can see for a brief moment, OK, they have some problem. But for a brief moment, you can see the download time of those libraries. And even at the bottom, you can see the alternatives to a certain library. So that's bundle phobia. And we can use async and defer attributes for the third-party scripts. Of course, one of the most effective techniques that most of us use is code splitting. So if we have a huge bundle size, we can split it into like smaller chunks, right? And lazy load those chunks once we need them. And for a long time, the most common technique was route-based code splitting. So let's say we have a route component that is on a second page and not initially on a page that we are loading the web app. And we show it on the second page. The import that we are showing now is what we call static import. So that means that that component will end up in the whole bundle of initial load of the web app. How can we split that? Is to use dynamic loading, and we code split that specific component into a separate bundle. And once we go to the second page, then we load that component. And we can wrap it in the suspense to show that loading. But as we said at the beginning, let's critically think about this and say, what if we do all of this and it's still not enough? Now we go to our first example for today. Let's say we have a web application like this, where we have 3 distinct sections, but on one page. If we run a lighthouse of this page, I'll just quickly do that. Just give me a sec. Let's see the performance of this web app. So it's like a simple app with 3 components, 3 sections, not much logic behind it. But we can see that it's taking quite some time. Something is happening. We will wait a sec. It's getting there, no worries. OK, so we can see that the performance is not so good. So what happened there? OK, I know that I made a performance bottleneck on purpose here, because in the third component, I wrote just Ola a million times. So this component is a bottleneck, but I know it up front. But let's say we have the same app, same 3 components. And what would happen if we run Lighthouse now? Just give me a sec again. But this one should be faster, a lot faster. So we should get the report. OK, it's 100. So what happened there? Let's observe what is going on in the network tab. So if we refresh the page, just let me empty the cache. OK, in the first example, we can see that there is only one bundle. So that's the bundle for the whole application. But in the second example, we can see that there are multiple bundles. So they are components split-wise. And if we go to the console at this point and just scroll a bit down, and once we get to the second section, then we start downloading the bundle for the third component. So in that way, we optimize that initial load. We show initially what we need in the web app, and we lazily load everything else that we need afterwards. So how did we manage to do this? There is a concept called component-based lazy loading, which is basically the same. We do the dynamic import. We have a reference to the second section. So once we scroll down to the second section, so once that section is visible, we have a special hook for that. We can show the third component. And in that way, we offloaded the initial load of the web app. Also, a secret shortcut could be to use less libraries. So there is a library on NPM called isEven. Maybe we don't need this, because we can solve it like pretty easily ourselves. Of course, I'm not saying that we shouldn't use libraries at all. Libraries are good for certain use cases when we don't want to write a custom code of our own, but if it's solving a specific problem. For this, we might not need a library. Shockingly enough, there is odd library as well on NPM, and you can observe the size of that library. It's 6 kilobytes. I don't know how these guys pulled off this, but don't tell me, I don't want to know ever, honestly. Especially if you consider that libraries like UseS, WR, and React Query have the similar size. But they are really solving some specific problems. OK, how many of you thought that hook useVisible is a library? Anybody? OK. Actually, it wasn't a library. It's pretty easily to build this hook on our own, maybe 30 lines of code, if we leverage some functionalities that is provided by JavaScript, by the Web API, because we have that functionality built into our browsers with intersection observers, so we can figure out when the element is visible or not. OK, what about images? Again, if we Google a bit, we can find that we can take advantage of the next generation formats. We can use image tag over background image. This will not specifically do anything for the loading performance, but it will get us more control over images. But then once we get that control, we can use source set attribute to create responsive images. We can additionally support resolution switching with the sizes attribute. We can put some priorities on the images, especially for the images above the fold, so that images that we need when we initially loading the web app. Also, we can do reverse logic, so we can lazily load images that we don't need initially on loading. And we can use various tools to compress the images. But then again, what if we do all of this and it's still not enough? What if we have an example like this? We have an image of a galaxy, and we did all the previous step, but it's still like high-resolution image. Once we try to load this image, and especially on a slower network, we can experience something like this. OK, how many of you think this was great user experience? Anybody? OK, people who have raised their hands are much better people than I am, so this was not a great user experience for me. But what if we can make it like this? So once we load this galaxy image again, we have that kind of a blurry version of the same image. And in the background, we are loading the real image, the big size image. And once the network kicks in again, then we just swipe it and show the full resolution image. So how can we seamlessly do this? There is a very cool pattern called progressive image loading, or low-quality image placeholder pattern. In our example, we had that image with a galaxy, but we switched it with our super cool component called Pro Image. Again, how many of you think this is a library? OK, some of you. It is shockingly easy to create a custom component that will do this for us. Basically, what we do, we show both images, the blurry one and the real one, but we just hide the real one behind the blurry one. And we have a state that full resolution image is not loaded initially, but it will be triggered once the onload event is finished. So once the fully resolution image is loaded, we will trigger onload event, and then we will just swipe states and show the full resolution image. OK, what about data? Often we work with the APIs. We need to fetch some data. There are some third-party data, third-party APIs that we work with often. So what can we do about it? We can use GraphQL, to just cherry pick the data that we need. We can prefetch data with the help of the link HTML tag. So we just need to set rel attribute to preload and we define the URL and as attribute to fetch. So that will prefetch the data. We can, again, compress those payloads. We can use paging and filtering. But then again, what if we do all of this and it's still not enough? OK. Here we have an example of svemirko.rs. Roughly translated to English, svemirko means spaceman. And it's a little bit futuristic app, few thousand years in the future, where you can choose a habitable planet to go to vacation to. As you maybe noticed, I created a little bit distraction for you once I hovered that link, because that API is like long fetching and it's a lot of data. So there are like two common patterns that you prefetch data on the page load for the second page, or once you hover a link, that will lead to the second page, because that is kind of like a hint to a user, OK, I'm about to go to this next page, and I will need that data really soon. So now, once we click this, the data is immediately shown. So there is no loader. There is nothing going on there. And now we can search our planet, and we can say, OK, TOI 1221B, that's the planet I wanted to go to the vacation. I will go there. And what's cool about this example is once we go back and forth, the data is immediately there. OK, how did we manage to do this? There is a really cool library called useSWR in React, which helps us with the caching. So once we hover the link, we will trigger the function prefetch, which will fetch the data from the API. And then we will use mutate function from useSWR to put it in the cache. And you can see that this list component from the second page is not fetching the data. It's not communicating with the API. It's just retrieving the data from the cache, from the useSWR config, by the key that we put it in. So that's a neat trick. Since we're at caching, basically, HTTP caching is eliminating the network latency. So we might not need to go to the server again to fetch some data if we consider that data as fresh, or if it's not stale, if it's not frequently changed, stuff like that. It only affects HTTP safe methods, so get or head. And we have a control over cache with different headers. So we can configure our web server to use no store, which means a header that says never store anything in the cache, so always ping the server. No cache, which means we will cache the data, but we will check with the server if there is a fresh data. We can use maxage, so basically put a timestamp when we consider that the data is stale from that point on, and stale while revalidate header. Does this seem familiar to you in some way? Yeah? Use SWR, hence the name of the hook. So it's basically you define a time once the data is fresh and once the data is stale. Again, if the data is stale, you will retrieve the data from the cache, but you will check with the server if there is a fresh data. Content addressable storage pattern. Has anybody heard about that? No? OK, that's pretty easy to check. Just give me a sec. So basically, if you see this hash on the bundles file, this hash means content addressable storage. So when this hash changes, that's a hint for a browser to, OK, there was a new deployment, there was a new version of an app, so we should go and fetch a new version of an app, new files. But the problem with caching, it has limited control. So the secret shortcut for this is to use service workers, because service worker is like a proxy between a client and the server. It will intercept every request, and we can have more control over cache with the service worker. It provides us with offline capabilities, and we can do all of these performance scenarios. This is a link, so you will have a which leads to the GitHub repo with all these kinds of scenarios. So if you want cache first, offline first, network first, and stuff like that. Also, what is the popular in today's community is server-side rendering, and we have it's basically a concept where we don't fetch the huge amounts of JavaScript initially. We render on the server HTML and CSS that we need initially for the loading of the web app, and then we progressively hydrate with JavaScript and attach event handlers to a specific components. And probably two most popular frameworks these days is Next and Remix, which have some similar features. But basically, what makes a game changer for these frameworks is a concept called edge computing. So edge computing is like a CDN for dynamic data. Once we deployed our app, it's like a static data, and we can use, I don't know, maybe AWS CloudFront to distribute those static files across the world, right? But if we want some dynamic data, the dynamic processing, we still need the same origin server. So these frameworks are basically like converting our app into Lambda functions, and we can distribute dynamic processing across the world. Also, there is a very cool trend with the 0-kilobytes JavaScript, and with the leaders like Quick and Astro. With Quick is basically with its resumability concept, and it's basically initially loading 0 kilobytes of JavaScript in the browsers, and they lazy load everything else. So once you need it, it's like a pull mechanism against push mechanism for the server-side rendering and the progressive hydration. So it's a pull mechanism. You get the JavaScript, the part of JavaScript that you need at the moment. And of course, with Astro, with its island architecture, which is component-based, it's also UI agnostic, it's server-first framework, and it's zero JavaScript by default. And also, of course, server-side components with server actions, where we move the logic of data fetching to the server, and we just stream those data to the client, and offload a part of the client bundle size. And in that sense, we offload the initial loading of the web app. OK, we're coming to an end. So I saved, for the last, I saved the best performance hack ever. Are you ready for this? Trust me or not. OK, we could just put a delay around every important action in our system. And once our users get mad and our manager, we can just remove those timers, and we will be geniuses. We will get the promotion and a pay raise. Why not? For more advices like this, please follow me on LinkedIn. Thank you. Thank you.